but we can talk about that stuff. Let's see. Maybe if my thingy actually starts. Yeah.
Like I'm starting to understand what I mean. What I like when I'm typing system.out print line. I understand that it's getting the system. You're going into the system and you're going to output a line that's being printed, or
Yeah.
line. I understand that. It's more so the scanners. That's what I'm
basically 20 years ago, or God, 40 years ago, when they started talking about Unix systems, right? Mm-hmm. You had a screen, a keyboard, right? And so they defined standard input is your keyboard, basically. And standard output is your screen. There's actually standard error too. So eventually Java embedded those things into the system class. They are static fields. In is some sort of string for reading. Out is some sort of thing for writing. It's actually a print writer, I think, the name of the class. And we haven't seen classes much, so, right? Now, the thing is that system.in is not a very useful thing because it only lets you read letters at a time, which is mildly useful. You can build everything on top, but it doesn't, it's not terribly, you need to build everything if you're just reading one letter at a time. So the scanner class wraps the system.in into something where you can do next int, and it will actually read a bunch of letters. Until it reads one that's not a digit, and then it will return you the right integer. When you type 123, right? You didn't really type 123. You typed 1, 2, 3, right? And so the scanner class is the one that goes and says, oh, what they meant is the number 123. Does that make sense?
Somewhat.
So when you create your scanner and then do, say, if the scanner you called it in.nextInt that says keep reading until you find something that's not a digit and convert that into an integer. And if you do .nextFloat, that will read a float. If you do, I think next line, that will read a full line until you press enter.
Another thing it took me a second to figure out was whenever you had a class on, when you were using Eclipse, you had to have the, I don't remember the exact line, but the, I think it was like void. It was the public static void name string. Like if I didn't have that, I couldn't run it on Oracle.
Yes, actually, when you say run, right? What it means is start from here and run.
Yes.
So you have to define this. Almost exactly like this. The only thing you can change, this is the args, is actually a variable name. So you could choose any name you want. Right? And we will see, don't worry now, this is for arrays. So this says you take an array of strings. For now, it's cut and paste. Or actually, you can tell Eclipse to generate that stuff for you.
I wish that was default because I forget sometimes, but I've gotten into the habit now of making sure that's clicked.
It is, if you have a bunch of classes, you only have one main normally. So you don't, if you start having bigger programs with more classes, not all of them have a main, or most of them will not have a main. You only want one main in your program. So that's why it's not a default. Any other questions? Any other interesting things? GitHub stuff. It is mildly annoying for now, right? Hopefully after a couple of weeks, it will be natural. And it is important because that is how you normally work with other people, right? When you become a programmer, you're working in a team, and everybody is accessing that same source code. So it has to live in some sort of server that's shared by everybody. Git is one of the 17 different programs that we have created for dealing with this stuff. And so it may even be a good idea if you're taking any other classes to start putting your stuff there. Or if you have a team thing, to do it, right? And share your thing on GitHub. It keeps versions of everything. And it actually has. Did you guys explore the interface? Like, if you go to GitHub, I am recording, right? Sorry, my paranoia. Yes. I am recording. Yes, that is good. If you go to like Bitbucket, you can actually see, and you have a nice interface for your things. I'm actually gonna cheat and go to somebody's.
That's fine.
3-wit? Yeah, cool. I remember your name.
And has some memorable last name, that's for sure.
Yes. So you actually see all the files that are there. And let me cheat, just in case somebody hasn't submitted or something like that. I make the deadline Sunday so that we could discuss solutions in class. I think I'm gonna do it anyway. I think I'm gonna discuss solutions in class for this. You actually get to see multi-source code, so you can confirm whether you submitted what you thought you submitted on Bitbucket. And eventually, if you're working with other people, you can create your own branch, and then you send pull requests where you say, would you please add these differences? And it will tell you there is this difference. Like, maybe, let me see commits. Right now, we only have one branch, right? Let's see. Did you do it all in one day? No. This is actually the history of all that you did. And so you can see things that changed and the actual changes. But this is the cool stuff that Bitbucket does for you.
So all your teammates can monitor everything you do.
Yes, which is important because you want to keep track of who did what and who worked on which piece, who screwed up what, all of that stuff. So that's how it works in real life. Chances are, whatever you end up doing, you are going to be using one of these guys, so you might as well get used to it. Okay. Were there any particular things that were complicated or something like that? No, you got the things to pass, right? I think people were having trouble with the
I had trouble with the last part.
the main.
Yeah.
Yes. So let me see. Is this? Yeah, this is mine. Let's see if I can make this auto hide so we get more screen. Maybe. Oh well, never mind. We can make this out wide. So, can you guys read?
Yeah.
Cool. The main required you to call, read, and add to get a value, right? And this is what we are doing here. And I was printing just for kind of debugging purposes, right? Call, read, and multiply to get another value. And then call print all operations. Why?
I don't know. I've never seen a variable, a method assigned to a variable.
This
Yeah.
calling a method.
Mm-hmm.
This is what we were doing, right? In all of our examples, when we call a method, right? That's how you call it. And then you can do whatever. You can either use it or assign it. In fact, you could.
Well, I called it. I just put
You,
an add.
yeah,
I didn't assign it anything.
that makes perfect sense.
Oh, I just did N1.
That would make sense. You can also do it like this. Not have the variables.
Those are actual commands too that we can use on Java.
Yes and no. Once you define them, right? What you are doing in reality, what you're doing in programming is defining all your commands, and you're supposed to understand the domain, what you're trying to do, right? When you go to real life, right? Understand what you're trying to do. You define your own commands basically, and then you just call them. And a lot of programming is figuring out what's the right level of abstraction, what's the right commands to define so that your task becomes really easy.
Okay, see, I don't think I made my own commands in the assignment. I think I literally just had integers and I just was able to.
No, like you did, right? You did something like this, right?
That's not like, I think.
You created your own command, right? That's whatever it did, it's your own command, right? Maybe it didn't do the right thing, but
Oh, no, I tested it. It did
Yeah.
Add and
Yeah,
multiply and everything.
so this is kind of, once you get this, most of the other stuff is easy. Once you get this kind of changing levels of abstraction, then everything's easy. Okay.
I've never seen the closing the scanner in before.
Oh, yeah. These kinds of things you don't always need to, but it's kind of good manners. In fact, I suck. I didn't put it in my examples, so that's why you didn't see it.
But the program still ran though.
It runs. It's just that if you leave things open, it could be occupying resources and not. You're supposed, when you open a file or something, the operating system actually uses a little bit of memory for a buffer and that kind of stuff. And so the sooner you close it, the sooner it releases that. And so.
So I got a warning because I didn't have that. It said something like resource bleed or something like that. Like,
Yeah. Usually for this kind of stuff, it doesn't terribly matter. It's a good idea to start to get used to this kind of stuff. For a server program that is running forever, right? Because when your program ends, the operating system says, oh, you're dead. Now all those buffers and things that you requested are dead now too, right? And so it recovers them, right? It recycles them. But if you have a server program that's supposed to run forever, and you don't do that, then you may actually be leaking stuff.
When in C++, for that data structures and algorithms class, where you have to close it. After you delete, it's actually delete new. Once you create new scanner, you have to delete.
Yes.
Afterwards.
Yes. This is similar to that. In C++, you have to delete because new allocates new memory from the heap. Java has garbage collection. So in Java, once nobody's using your variable, it will eventually get deleted. But it's just the eventually part that's a pain. In C++, if you don't, then you're leaking the memory, which you probably shouldn't. Oh, God. You're being exposed to that already? You're in deep doo-doo. Yeah.
That class is pretty tough.
That class is supposed to be it's not so much that class is pretty tough, and then you guys are taking it in the wrong sequence. You should have taken this one, and this would be easy, and then all the concept makes sense and things like that, and then you go to the tough one.
Yeah.
You guys,
Classes or subclasses.
these two guys had some knowledge experience, some programming, so they're taking this one concurrently with data structures. Data structures is the next class from this. So you're supposed to take this one, take your time, learn this stuff, and then take data structure. But they like to make their own life hard. There is masochism sometimes.
Perhaps we'll win to this withdrawal. That's what I'm thinking.
Next week.
Yeah.
Talk to the professor, right, and decide, and decide with all the other stuff whether, I don't know, how important is it for you, one more semester, one less semester, that kind of stuff. But it's a lot better for you to withdraw than to fail,
Yeah,
right?
exactly. I think hopefully it won't be too bad, but it's going to be a lot of work for them.
And this is a CS course you guys are talking about, right?
Yeah.
Okay. I'm like
Oh.
looking at my
Oh, you're FWE? You guys don't need it?
well, I'm in IT. I only need
Oh, okay,
So,
okay. Yeah. Now
I'm
you.
substituting this for software design and development.
Okay.
Was that a good idea?
Maybe not. I have no clue what software design and development.
Well, we had a choice. They dropped one of our classes because enough people didn't register. This
Oh,
was
okay.
an online only class, and I remember my advisor was telling me that class was going to be difficult, and so I was like, I'd rather be in person to take that rather than online. So,
This class should be okay. This class should be
Software
okay.
design and development, I took it in the fall, and it actually moves a lot slower than this class.
Oh.
So, I mean, we were still on like defining variables in the third. We were not on methods until.
Well, I switched to me.
you move fast.
I move fast. That's one thing. But no, the other thing is, to me, defining functions is fundamental, right? Once I have a function, then I can do everything from there, and I can do everything individually. Now we have the function, so I can show you an if statement within a function without having to, so I can isolate stuff. And so for me, functions should be the first thing, and then now we can talk, right? Now we can.
That's interesting, yeah. Because we learned if statements and if else and switch and all that stuff before.
Yeah.
So
I normally do functions first, and now we can have tiny things, right? And even I like Java 9 should have a REPL. Java 8 doesn't, but Java REPL kind of helped make this horrible stuff wait until the second week, so at least, right? Some of the functions and stuff. Okay. Some of you have already looked at this stuff because you were using if statements on the first assignment. Not all of you, but some of you. Now, here's the idea. What we want many times in programs is have some condition, and depending on that, either do one thing or another, right? Does that make sense? In English, you would say it if, right? So if today is Monday, then I should come to class, right? If it's not Monday, then I don't come to class, right? So this is the same kind of stuff. We do the keyword if. We actually have to put parentheses. These parentheses are part of the syntax. Then we put the condition, and that can be any of the expressions that we have been using, right? Open braces, they are not necessarily needed, but we normally put them. Then we put whatever we do if the condition is true. And optionally, we have else and say whatever we do if the condition is not true. A kind of dumb example is this. I'm going to define a function Boolean to yes, no. Oh, no, it's not dumb. Because we couldn't do it any other way, right? You are giving a Boolean, and if it's true, you should return yes. If it's false, you should return no, right? So we do if B, whatever this condition was, right? Then return yes, else return no. Does this idea make sense? Cool. Parentheses are required. Braces are not strictly required, but usually you want them there. The else clause is not required. In that case, if you don't have an else, then nothing gets done, right? If the condition is not true. And then indentation is important. Here, if you notice, we put this thing one more level in, right? And that helps you read the code. We are programming for people and only incidentally for computers, right? The point of this is for somebody to understand what you did. And that somebody may be you in a month, right? Does this idea make sense? Some people are very picky about indentation. I tend not to be terribly picky. I don't terribly mind which way you do it, as long as you are consistent. The point of it is to be consistent so that you can read your code faster. I tend to use almost standard Java thing. There's a lot of stuff about should this opening brace be here or be here? Should you have one more line, right? That kind of stuff, do whatever makes you happy. But
So we can close everything at the end.
what do you mean?
Like you see the opening brace you have right before the else.
Let me do this. Let's go play. What do you mean?
One before the else.
This.
Yeah. Can you remove the probe all the way to the end?
You move like this, you mean?
No, remove down completely.
If I remove this brace,
Put at the end.
put it at the end here. Here?
Yeah.
If you're happy with that, that's cool. But keep in mind that there may be several lines. And so that kind of...
Or if you take it, can you bring it all the way down below the return?
Normally, what you want to do is to close, because it's part of this, right? So it's closing.
Close down first.
So you want it aligned with the if,
Okay.
right? Now, some people do, you normally want to align your braces so that you know what's inside and what's outside. Some people do this stuff.
And that's
Some people say, well, this wastes too many lines, right? I tend to do this, which is more or less the standard convention. The only thing that I have tried not to do in this class, this is the standard convention for Java. I think this makes sense. In particularly for you guys to mark that's. It is important that you indent because it's going to help you read. For me, it tends to be a standard thing, right? If you come and ask me a question and your code is not indented, I know that it's wrong automatically, right? Because you weren't thinking about what you were doing, right? It doesn't have to be any particular way, but you should be consistent. if you feel terrible about something, Control Shift F in Eclipse will indent it magically for you. Right? There's programs that are really good at doing this kind of stuff, right? So you do that and it will figure it out. Does this idea make sense? Now we can go play a little bit more.
Do you ever see anyone place a comment after the closing brackets to tell you?
Oh, a lot of times people do that. Like they will do this. Place. I'm ending the if ending function or something like that, right? I think that's overkill, but if it makes you happy, by all means, right? When you have really big things, it helps. Usually, you don't need them anymore with this kind of things because you can do this. Your IDE will let you close things, and so you can close the inner thingies and look at the outer structure. Once you have 7 levels of nesting of ifs or something like that, which you shouldn't have in the first place, right? But if you're having so many levels that you're getting confused, then your IDE can help. Chances are that if you're having so many levels that you're getting confused, your code is wrong. And you need to think about it and simplify, write more functions and write more methods so that no particular thing is too big. Does that make sense? So once you write if statements, what goes inside can be whatever you want, including other if statements, right? We call this nesting of if statements. This if statement is inside the else part of the first if. Does that make sense? So we are trying to write this sign function that returns 0 for 0, -1 for negative numbers, and 1 for positive numbers. Does that make sense? You remember in math, they tortured with that at some point in time? No? Okay. Believe me, they did. So how can we do that, right? Well, we can check. If the number is 0, we return -1. Else, we know that it wasn't 0, right? So in here, we already know it wasn't 0. We check, is it greater than 0? If it's greater than 0, we return 1. If it's not, so it's neither 0, it's neither less than 0 nor greater than 0, so it has to be equal to 0, right? And so we return 0. Does this idea make sense? Many times you end up with these kinds of nesting of ifs. More than a few levels are going to be confusing. And they're going to be confusing for you, for your customers, for everybody, right? So this is normal. You get confused, right, when you start. And normally you have somebody with business domain, right? So if you're building a storefront, you go with somebody who manages a store, right? And you ask them, what do they do? So once they start trying to manage this in programming is hard. Trying to manage it in English is even harder, right? So more than a few levels, you're going to be in trouble. Usually maybe 2 levels, and more than that, you start crying. Now, there is one thing that is actually similar, but we count it as different, and that's chain if statements. You do immediately an if right after the else. And that allows us to basically do more than one condition. For example, for the same sign statement, right? Sign function, you have 3 choices. You're either less than 0, greater than 0, or 0. Right? So you have 3 choices, not 2. And so we can write it as if number is less than 0, then return -1. Else, if number is greater than 0, return 1. Else, return 0. In reality, right, this is a nested if statement. Where is the nesting? If we don't put braces, right, then if we don't put braces, then this statement is only one. So in reality, there are imaginary braces here. Does that make sense? This is completely equivalent to this. But that would look uglier, because we consider the three possibilities as being at an equal level as opposed to nested. Does that idea make sense? Chained if statements tend to be a lot more common. Or I would write chained if statements and not feel bad. I would probably feel bad about writing deeply nested if statements, although they are officially the same. And just to confuse you, there is one more thing. The ternary operator in Java is the question mark operator that actually takes 3 arguments, a condition and 2 values, and yields either the first or the second value depending on the condition. Does that make sense? So for example, for writing the function for the absolute value, we could say return, and so this whole thing has to yield a value, right? Is the number less than 0? If so, return minus number. Otherwise, return number. So it ends up kind of being a nicer or shorter form of the if statement, but it actually yields a value. It's an operator that returns a value. Does that idea make sense? You don't have to use it. When you use it, you could normally do it with an if statement anyway, but you will at least see it a lot.
The minus sign in front of the number right there.
Negative.
That's a negative number?
Yes.
Oh,
So
okay, gotcha.
you would return the negative of that. So if you get 2, you return minus 2 if you get, right? So in this case, the number is less than 0, so it's negative. When you return minus number, you return a positive one.
Okay.
Which is what the absolute value does. Does that make sense? Cool. Another example, and let's actually try to do this. I don't know if you ever played this as kids. I actually didn't know this as a kid. I knew this as a drinking game. Oops, sorry. I still don't drink, but this was still a drinking game. When you're drunk, it's hard. Fizzbuzz. So you start counting. So you start counting 1, 2, 3. But if the number is divisible by 3, you're supposed to say fizz instead of the number. Does that make sense? If the number is divisible by 5, you're supposed to say buzz instead of the number. And then if the number is divisible by both 3 and 5, you're supposed to say fizzbuzz. So if we were playing, I would start 1,
2,
3.
no 3,
No. 4.
fizz.
Oh, fizz. Okay.
Because
gotcha.
it's divisible by 3. Then you would say
Oh.
Buzz.
Is buzz.
fizz, just fizz, because it's not divisible by 5. It's only divisible by 3, right? No,
No.
you go 7,
7.
8.
is
think it's just gonna be fizz.
No, it's 10, right? So it would be buzz.
Oh,
But it's actually, and the other guy needs to keep track, right? Fizz, buzz of which number were we on, right? And does that idea make sense? At some point in time, somebody started mentioning that as a interview question for kind of checking whether there's a lot of people who have taken a programming class who actually end up not knowing a thing. And so this was kind of a quick way of, it's like, okay, do you at least have a clue about programming or not, right? After you finish this class, you should be able to do this with one hand tied to your back, but, right, it's kind of a first filter. Of course, now everybody knows that it's an interview question, and so everybody memorizes it, so it's not a good interview question, but it's still fun, right? So could we write a function that does something similar? So we're going to write a function that takes an int, returns, right, either fizz buzz, or the number. So what would we do? What statement do we use? If, yeah, okay. So which condition would be good? How can we know whether a number is divisible by another number? Do we have any operator that would tell us?
If the value is 0.
Yes, right? So the modulo operator, right? So if n% something equals 0, we're going to do something, right? What do we want to do here? N% what? Which way do we want to go? Okay, we can say if it's divisible by 3, right? Then what do we do? Now we know that it's divisible by 3, and in here we'll know that it's not divisible by 3. If it is divisible by 3, what do we do?
Return 3.
Well, that's a reasonable approximation, but there is a problem. It could be divisible by both 3 and 5. So if we just return fizz here, right, it would be wrong. Does that make sense? So what do we need to do here? We know that it's divisible by 3. What do we do? We can check if, and then what? Exactly. Cool. If it's divisible by 5, right? Then what do we return? Does that make sense? Now, if it wasn't, what can we do? Here inside the else, we know that it was not divisible by 3. So what are our possibilities? Else, okay, so what will we check now? If, okay, if it is divisible by 5, then what should we return? Otherwise, what do we return? A number, but it's actually an int, so we'll do this, and that will make it into a string. Java does some magic for converting things to strings. For now, assume that it's magic. It's on the node, so you don't need to.
This equation that we're doing right now.
This function, yes. Yes. But the point is to do it. The point is to use your brain, right? You can read it. It's in every book known to mankind. But this one is yours. This one, you guys wrote it, right? You can probably get a job now. No. Not yet. Wait until the end of the class. Does this idea make sense? What are we using here? Nested ifs or chained if statements?
Change it.
Are they chained or nested?
Which one is it? If else. Is it?
If else is normal, right? If else is normal. The nesting means here we have an if statement, this guy, inside another if statement, this guy. Does that make sense? And then we call it nested, like Russian dolls nesting, like Matryoshka dolls. Does that make sense? That kind of nesting. So if statements inside other if statement. This whole if statement is inside the other if. And then this other whole if statement is inside the else, right? So these are called nested if statements. Does that make sense? We could also write this with chained if statements. If we start the other way, so we could say if is divisible by 3 and is also divisible by 5, right? We can return Fizzbuzz, right? Else, we know that it's not divisible by both of them, right? If it is divisible by 3, then we return Fizz, right? Now, else, and here we know that it's not divisible by both of them and not divisible by 3, right? So what are the options that we still have? Yeah, if it is divisible by 5, actually we can cheat. Yep. Ah! Oops, and both of them we need returns. Does this make sense? Yes. You can do Fizzbuzz. You're good. This is cool. You're getting the logic. Again, how do you become really, really good at this? Practice. Do 1,000,000. Go to what was that? Coding Bad, right? And do 1,000,000. Come up with your own examples and do 1,000,000, right? It's how do you become good at anything? Just practice, practice, practice. So just whenever you have a chance, do another 1,000,000. Drop and give me 20, right? Until it becomes second nature and obvious, and then it's like, ah.
Good question.
Yes.
Can we do just question mark, not the question mark? It's comma between to replace the and, or it doesn't make
No,
sense?
no. You cannot do a comma to replace the and. The and is 2 ampersands. Yes, in Java and in C++ and most of those languages, 2 ampersands mean and. like logical and this and this. Does that make sense?
What happens if we use all? That would check the whole program or?
Yes, like for something like this, or actually, yes. Like this one, right? What would happen, imagine that we replace this and with an or. What would happen then?
I think it's gonna be either one of the conditions or both.
Either one of the conditions. So if we pass 3, it would still tell me fizz boss.
Okay.
If we pass 5, it will tell me fizz boss. If we pass 15, it will tell me fizz boss, which is wrong. And by the way, once we are returning, when we have a return statement, then we are done with the function, right? And nothing else gets executed, right? So you need to be careful by whether you mean and or and those things. Just need to be really, really careful. Which is a great thing about programming. It's not that it will teach you how to think, but it will force you to think clearly, right? Many times in English, you can fudge things, right? And then hope that the other people doesn't understand, and actually sometimes hope that they don't understand what you mean, and then life is good, right? Because you got away with something. In programming, you have to be very, very precise, which is good and bad. It's good to train your brain like that, and then to decide where you want to do or not. If you become a lawyer, you get trained in this, and also in when to use this to your advantage to confuse the other person, right? If you're a programmer, then you don't want confusion. You want clarity. You want your user to understand what you're doing. But does this idea make sense? Cool. There is another statement in Java, the switch statement, which is kind of syntactic sugar for when you have a bunch of different possibilities. When you have a bunch of different values and you want to do differently depending on the value, it looks prettier than an if, else if, else if. Does that make sense? That is only used. It's actually very limited because it only goes on one expression. So you would do switch, write the expression, and then case this value, case this other value, then do this stuff, break, then case this other value, do this other stuff. So for example, if we had to do a function for getting me the name of a day of the week, right? And it's weird, but weeks officially starts on Sunday, right? So you're gonna give me an int day, and 1 is Sunday, right? 2 is Monday until 7 is Saturday, right? We can use a switch statement to implement this function. Switch day, and then case 1, return Sunday, 2, return Monday, right? It is slightly prettier than if, else if, else if, else if. Does that make sense? We could just do it with ifs and else ifs, right?
That is, what is the break you mentioned earlier?
Well, break, if you don't write a break, it will keep going down. This case, if we're using return, you don't need to do a break because when you return, you're done. So it doesn't continue. If you don't write a break, it would fall through, which chances are that's not what you wanted. You want only to do one thing. Although there is weird programming stuff where you want.
What's more common, writing it like this with return statement or with a break?
Depends on what you're doing. I'm a functional guy. I write tiny functions all the time, so I always do return statements. But if you're doing, imagine that you're writing, and if you're written our kinds of main functions, right? You have a menu, right? Like, okay, I'm going to give the user a menu. I'm going to ask, what do they want to do, right? I'm going to tell them stuff like, right? 1, add, 2 subtract, 3 multiply, right? That kind of stuff. Then that would be you want breaks, right? Because I'm going to do a switch, case 1, add, right? And then I call the adding function, and then break. Case 2, multiply. That is. So
That way it doesn't go to multiply after.
exactly, it doesn't
Add.
add and multiply, it just adds, and then you get out. And we are going to see how to do looping so that you can go back to whatever you were doing.
Do we always have to include the default part, or we don't have to?
You don't. If you don't, then if none of the options are there, nothing will be done. In a function, right, where we are saying we will return a string, we have to return a string no matter what. So Java would actually complain if you don't, in this particular case, if you don't put a default or if you don't somehow return a string. If there is some values that will make you not return anything, Java will complain and will not let you compile. Does that make sense? But yeah. We can actually use fall through, right? Imagine that we want to do how many days are in a month, and we don't have leap years, right? Close your thing, right? Start counting. Now, what's your mnemonic for remembering which days, which months have 31 days? If you count your knuckles, it works. So January, March, May, July, then August, October, and December have 31. So we have all those cases into this, so it actually gets recorded. Right, and all those cases will return 31. Then if it's the second month, which is what? February will return 28, and then otherwise will return 30. And this is my paranoia, and we could have put this as a default, right? If what you gave me was in a month, then I still need to return something, right? We'll see that you can later raise exceptions and things like that, but if not, I'm just saying I'm returning 0. On the 13th month, we have 0 days. Does that idea make sense? Cool. Now, let's go have fun. Up until now, we can only do one thing, right? Now we're going to see recursion, which is incredibly cool and weird. But we can, and it has been proven, right, that we can calculate any value with no more than if statements and recursion. Recursion is allowing a function to call itself. Does that make sense? That's scary and weird. If you remember probability, counting, and that stuff, the factorial function. What was the factorial function? What is 3 factorial? 6, right? 3 times 2 times 1, right? So you could say, okay, it's just keep multiplying by n minus 1 until you reach 1, right? Does that make sense? 5 factorial is 5 times 4 times 3 times 2 times 1, right? Now, we can also define it in terms of factorial itself. 5 factorial is 5 times 4 factorial. Does that make sense? And 4 factorial is 5 times 3 factorial, right? That works. We need some base case. We need somewhere where we stop, right? We need someplace where we know. And the standard definition in math is 0 factorial is 1. And if you ever saw this in probability, you're always like, why the heck is 0 factorial 1? Because that's how mathematicians define it, right? Does that idea make sense? So now we can use this idea to write a factorial function. What do we do? If n is 0, and I'm being paranoid, so I'm saying if n is less than or equal to 0, because I have no clue what's the factorial of a negative number, right? I'm just going to return 1. Now, if it's not less than or equal to 0, then I'm going to return n times the factorial of n minus 1. Does this make sense? Isn't this cool? Isn't this magical? When it goes to execute, right? If it's gonna say the factorial of 4, right? It's gonna come here and say, oh, n is 4. Is n less than or equal to 0? No. Then I'm gonna return 4 times the factorial of 3. Oh, now we need to find out what's the factorial of 3, right? So it's going to come inside and say, oh, now n is 3, is n less than or equal to 0? No. So I'm going to return 3 times the factorial of 2. And then 2 times the factorial of 1 until I get, 1 times the factorial of 0. Oh, that was 1. So now this is 1 times 1. Then this is 2 times the factorial of 1, which is 2 times 1, which is 2. And so the factorial of 3 ends up being 3 times the factorial of 2, which is 2. And then 4 times 6, which is 24. Does this make sense? Does this make some sense? Isn't this cool? Can we do other stuff? Let's try to define let me open something. Define something. No, not you. Here. It's coming. It just takes forever. New class. I'm gonna call it Feb1, and I'm gonna ask it to give me a main. Yeah. Imagine that we want to define power function. Traces, base to an exponent. So this is something like 4 to the third, which is what? 4 times 4 times 4, which is 64, right? Maybe. Probably is. We'll see. How can we do that? What is something raised to the first power? Itself, right? Can we raise something to the 0th power? To remember math.
Make it 1.
Yes, right? Something to the 0th power is 1, right? So we can have our base case. What would be our base case? Exponent, right? That's our exponent. So if exponent, let's use equal to 0. And let's not deal with negatives, right? If you want to be differently wrong you can do. So if the exponent is 0, what do we do? Else, how can we calculate something? How can we calculate 4 to the third power?
Some kind of command in the math
Okay.
package, right?
Well, no. This way. There's power, I thought power, but how can we do, right? 4 to the third power is what? It's 4 times 4 squared, right? Does that make sense? And so we can have 4 to the fifth power, right? Of 4 to the fifth power is what? It's 4 times 4 to the fourth power. Does that make sense? And 4 to the fourth power equals 4 times 4 to the third power, right?
So we're going back to the previous.
So in here, if it wasn't 0, what do we return? What's my function?
Base first.
Yeah, base times,
Same base again.
okay, base
Power is -1.
what is power? How many parameters does power take? Yeah, you're getting there. How many parameters does power take?
Oh yeah, two.
2, right? So we call power with which parameters? Are we changing our base?
No.
Base, and then are we changing our exponent? Does this make sense? Is it cool? Or what? What? Okay. So we can do stuff like system.out.println. Raise 5 to the fourth power. Now we are defining all of our things as public and static, right? And we get 625. Beautiful. Does this make sense? Other fancy things can we do with recursion? How about print countdown from n up to 0? Does that make sense?
And up to 0.
Down to 0,
Down
sorry.
to 0.
Down to 0. Right? What can we do?
It's good.
we could do, let's print n, right? And then how do we keep counting down?
N minus 1.
We would call the same function, right? What would happen if we try this? Well, no. Then let's break the system. What do you think would happen? You keep printing forever, right? Until you get to like minus infinity, right? Or until the computer gives up. Does that make sense? So we need some way to stop.
So you can go for default.
Default is on switch statements, right? And here we would need some way of returning, right? Some way of not doing that stuff, right? What can we do? We could put this inside an if statement, right? And only do,
If statement,
yeah, if what?
n equal to 0.
Okay, if n equals to 0, what do we do?
Yeah.
Return, get out, right? This is one way of writing it, right? And just to be paranoid, so if n is equal to 0, we just get out, or less than 0, just in case somebody calls me with -5, then I don't keep counting down. Does this make sense? We could also write it like this. We could call yeah, always safe. Yay! 5, 4, 3, 2, 1.
Is there a way to make it, or how would we go about making it say something when we hit 0? Because technically, that didn't really count down to 0. That counted down to just.
Oh, yeah, sorry. Right, that is true. All right. Pair programming is amazing.
Can you run it?
Yeah.
Please.
Now we are actually counting that to 0. Yes, thank you.
Why doesn't include 5?
It does include 5, it's just. Isn't this cool? What other kinds of things do we want to do? Give me an example. Let's do something.
Can we make it guess a number?
And then go up or down or something like that?
Oh, no, never mind.
We could.
Like, we're trying to do a number generator thing. Like, hey, guess what number I'm thinking of? But I guess that's not really it.
If do we want we could. Do we want the computer to guess or do we want
We're guessing.
we are guessing?
But I guess that would be
Okay.
more than
No, that's cool. We can do public void. Let's do play guess number, right? Oh, the scanner class in Java is brain dead, so we are gonna pass it as scanner, right? Because if not, recursion and scanners don't like each other. We're gonna pass it as scanner, and then we are gonna pass it number.
You say recursion and scanners don't like each other?
Yeah,
Oh, okay.
actually, scanners are brain dead in general, but they work. It's just yeah. It's just the Java scanner class is brain dead, but it's better than nothing. Oh, and it's complaining because it doesn't know about this kind of class. Yes, of course. Import it. F is good. So what can we do? We can ask the user, right? Then do int guess equals, what can we do?
Do you want it to be a program number or a random number?
Well, the number is given to me. It's this n. For now, we're gonna tell it the number. We won't do random slate yet. So, but we can ask the user, right? This is the number the user guessed, right? Then what do we do?
If parentheses n equals
Guess, right?
yes. Smiley face, yeah.
Okay, else, what do we do? We could just,
System out. Guess another number.
whatever. And then how do we make it system out print line? How do we make the function ask again?
Return system out print line guess my number. We just type that.
We just do play guess number, right? Which is our function. And we pass it the same scanner and the same n in this case, right? Does that make sense? If we want to be nicer to the user, we could tell it if
That's
it's.
shortcut, or we can
Sorry?
you miss the scatter, right? Or is that normal to write down like that or what? No.
The scanner?
This number? Yeah.
I'm passing it because scanners don't like recursion. Scanners mess up your input. Once you have a scanner on your system.in or something like that, it just destroys your stream and it does bad things to it. So you can't do it recursively. So we could call play, actually, guess my number. And since we don't know the number, we are going to say 5. We still don't know the number, so we're going to say 6. And then, yay, and it finished. And it's so good.
Is there a way to put that 7 at the beginning or no?
Well, officially, right, you have been printing on the screen, so you can't. What do you mean put it at the beginning?
That the number that the computer wants to guess. Why don't we don't declare that number?
This 7?
Yeah.
We are passing it to the function. We could use, yeah, it is here. That's why it was 7.
Okay, I see.
we could use a random number generator or something like that, right? Actually, it would be nice if we could tell the thing go high or low or something like that. But right, this is a really dumb guess my number thingy. Does this idea make sense?
It's just interesting. I've never seen new scanner system.in pass to a method
Oh,
in the main method. It's just different.
it's the same thing, right? Oops. We could do this.
Hey, that was
Cool.
That breaks it down a little bit,
Yeah,
so it's a
exactly.
little more understandable.
That's good. Then this is the right way to do it. Is this cool or what?
I'm curious, would that only, the way how you typed it out is, I don't know what I'm trying to say. Never mind then.
It doesn't matter, right? The advantage of this is that we have it as a thing that we can reference, so we can later do other stuff with it, right?
Yes.
Whereas if we don't have a variable, right, it's just a value. It's the same value, except that now we cannot get that same value again. This way we can. So. Plus, it's 2 lines and it's easier to understand. Can we do? Never mind. Never mind. Not in 5 minutes. We can do the reverse, right? Have the computer ask you, right? Does that make sense? So we could have do that. Now the computer is gonna try to find the number, right? And you should have thought of the number. What's the guess that you should do? You have kids, right? No. You play this with your kids. What should you guess? If you're trying to guess a number between low and high, what should you guess?
In the middle.
Yes, right? Right? So we could ask, is it this, right? Oh, and we need to pass the scanner again. Now it was not that, so what do you need to ask? Too high, right? Now, if it is too high, where should we go? Sorry? We should try between, if we get too high, then where should we try to, where should we be looking now? Between low and what we guessed, right? Does that make sense? Actually, since we guessed between low and guess -1, right? And actually, this is guess +1 and high. Maybe. Would you forgive me if I take out 2 minutes of your life to try this? Class officially ended at between 1 and 100. Probably static. We do static. Oh, and we need to keep passing our scanner. Okay, what's the number? Quick, tell me a number.
7, 8, yeah.
8. Okay, so is it 50? I think we have to say false. Oops. It's too high. True, right? 25. Is it too high? True. Is it 12? Is it too high? True. Is it 6? Is it
Oh boy.
fouled in? Never mind.
That doesn't seem fair that if the user messes up the input, that the program just explodes like that.
Well, the program is trying to get, right, a next Boolean, and there is no next Boolean, so it explodes like that. You can do stuff so that you try, right, and then tell the user, no, tell me a freaking Boolean, and then ask again or something like that. But shall we try again?
Sure.
But with like 75? Is it 50? False. Is it too high? False. 75? True. Yay! The computer's a genius. Yay! They're all good. By the way, this is called binary search, and it's an algorithm that's complicated. You have done complicated stuff in 5 minutes in a class. It's not complicated. Don't let people tell you it's complicated. It is, but it isn't. Because then it looks like it's right, and then there's an off by 1 error somewhere, and then you go crying. But
It's just something brackets.
yeah, and then
I mean, I understand why. It's just there's so many of them.
yeah.
The good thing about Eclipse is it'll put them in there for you.
Yeah.
JGrasp, you have to add them all.
It took me a while to get used to it because I used to write them by myself, and then it's like, what? In fact, it still happens to me a lot. I end up with two braces because I wrote one and then Cliff wrote one. I was like,
I'd almost prefer it just that way. I'd rather write my own.
Sometimes it's like, yeah, I know what I'm doing. You're a friggin' text editor. Just type what I tell you. Don't second guess me. I'm the man.
But now I feel like I was trying to type that out with you, and now I feel like I have too many brackets somewhere.
Actually, it will hopefully.
Well, I'm using Notepad++ right now.
Okay, all of them do. I don't know if you can see this, which is the closing one, is actually has a slight gray thing around it. So normally, most of your programming text editors will mark what's the closing one. And of course, if you index right, then it's harder to get lost. You can still get lost once you have 17 levels. Like this, we have 2 levels of nested ifs, right? So, yeah. But isn't this cool? Isn't it really, really cool? You have assignments with this cool stuff. By the way, I will be posting, actually right now, but on the website, if you go, and that way we can always post this stuff. If you go to samples, this is what we are typing. And I will upload it in a second.
That you're using right now. I don't remember doing that when I uploaded my assignment.
What do you mean?
Like going into the command prompt and doing all this stuff.
You need to, right?
It's Git bash, right?
Yes, it looks slightly different. It looks completely black instead of, right? That's when you do git commit and git push.
Oh, I actually have
A GUI thingy that does it for
I
you.
was about to say I was able to click pull and made it much easier.
Yeah.
Or push, I mean not pull. Telling me.
Yeah, look at pull. Stash. Ah, Control X. Yes. No. Control C. Control X. Yes. I think I did. Maybe. So now inside here, there should be a Feb1. Yeah. So what we did today is here. I'll be posting this stuff every time. So whatever we do in class, you don't have to.
Okay, cool.
I mean, we are still recording, but you don't have to take pictures or anything like that. It's cool if you want to take pictures. It's just...
Should we clone that?
You can. I wouldn't clone it
Yes.
because it's a mess
Yeah.
on purpose, right? It's not a clean thing. It's a mess. So I would cut and paste files whenever you want to play with them. You can view it this way. Yes. You are free to clone it. It's on GitHub, and it's actually a public repo. That's where all the notes are. I've been posting the notes online too, but there is an assignment due Sunday, this coming Sunday, that involves ifs, switches, and recursion. Isn't this fun? And I will try with all my might to grade the assignments maybe tonight and then bug you if I didn't get them or something like that. Let me go and kill this guy. Dog.